Children, welcome to video 2 now, and you see we are discussing electricity. We had gone till charges. Now let us try to understand. We have got a potential. We have got a positive field over here. Say for example, there is a body kept here which is heavily positively charged. All right, and then what happens? I take up another object. Say for example, I bring this. It has got unit positive charge, 1 coulomb of charge. I told you how a body can carry 1 coulomb of charge. So unit positive charge. Now when I am bringing it towards point A, I have to do work. To bring 1 coulomb of charge, say for example, I did 10 joules of work, then the potential at this point will be said to be 10 volts. So the unit of potential is 10 volts. You have to understand this it the other way. If I say if the potential of point A is 10 volts, what do you mean by this? Then you can simply say if I bring 1 coulomb of charge from infinity till A, I will have to do 10 joules of work against the electric field. See, it is the amount of work done to bring unit positive charge from infinity to the concerned point. You have to add over here against an electric field. We take positive field as reference, it's just by convention, and we talk about electricity. So this you have understood. So now how much is the work done to bring 5 coulombs of charge to a point at potential 25 volts? Now suppose I change this and the potential is 25 volt. That means to bring 1 coulomb of charge I have done how much work? 25 joules. So to bring 5 coulomb of charges, how much of work I do? So what I do now, I have been given the exact potential of point A is 25 volt now. That means what does potential at point A is 25 volt means? That to bring 1 coulomb of charge from infinity to point A, we have done 25 joules of work. So the potential is 25. So to bring 5 coulomb of charge, if I bring 1 coulomb, I do 25 joules. So if I bring 5 coulombs, I do 25 into 5 joules. So obviously the work done will be here as electrical work done, we can say, is equal to 5 into 25, that is 125 joules. So that means we can get an equation: work done is equal to potential into charge in coulombs. I will write this way: work done is equal to potential into charge in coulombs. In C means coulomb. So W is equal to V into, how do we denote charge? Q. So W is equal to VQ. Electrical work done is equal to potential into charge in coulomb. Similarly, now what happens? Suppose I am bringing this charge over here, and okay, and now suppose from infinity I bring about 1 coulomb of charge till A. We do 25 joules of work, so potential here is 25. If I take it from infinity to point B, further closer, I will have to do extra work, so it is 45 volts. So now 45 volts, what does this mean? From here to here, if I have to transfer 1 coulomb of positive charge from A to B, I have to do 20 joules of work. See the difference, 45 minus 25 is 20. So 20 joule is the work done to bring unit positive charge from A to B. That is the potential difference between A and B. So what is potential difference between 2 points? It is the amount of work done to bring unit positive charge from one point to another point against an electric field. So here the PD is 20 volts. Now again the same question can be asked: how much is the work done to transfer 5 coulombs of charge between 2 points having potential difference of 20 volts? So work done, straight away potential difference into charge in coulombs. Delta means difference. So potential difference will be how much? 20 over there, and charge is how much? 5. That means we do 100 joules of work. Also try to understand what is the unit of work done? It's joule. What is the unit of potential? Volt. Joule by volt is equal to coulombs. Or in other words, there is one unit of potential which is volt. Another unit of potential or potential difference can be V is equal to W by Q. That means joule per coulomb. That is also the unit for potential difference or potential. So there are two units now already you heard. One is a normal potential, the SI unit of potential or potential difference is volt, or it can be said as joule per coulomb. So this is what is very important informations about potential. But why we are talking about this is a very important aspect of creating or generating electricity through flow of charges. Now imagine if I am bringing positive charge till here, I have to do work. It's almost like this is the office and you have broken a window and the teacher is pulling you. So he has to do some work and he left you over here, you'll run back. But then what happens, you go closer to the office, he is pulling you with more effort and he has brought you till here. Now if he leaves, you will be running from here to there, that means from B to A. So same way, if I leave the charge over here, which is a positive charge, it will travel from high potential to low potential, provided it has a route, it has a conductor, it will run, and provided we can create potential difference. So it's very important. Positive field of reference means high potential. So negative field of reference will be low potential. Positive charges will flow from positive to negative, that means from high potential to low potential, and vice versa, that means negative should flow from low potential to high potential. These are minute things you can understand. Suppose I rub something and I make a positive field over here. You know, you have studied rubbing something and creating positive potential and creating negative potential. Both the bodies are joined through a wire, then you will get the electricity flow, electrons to flow, and that is what is electricity. So this is the second video for you all with a lot of numerical potentials over here which you can do. I'll provide you some assignments. So thanks.